Welcome to the second devlog of my game Sidestep Legends, a MOBA-inspired action roguelike game about dodging spells and killing minions. The game has recently been fully released on Steam, so this devlog series gives a behind-the-scenes look at how the game was made. Right now you are watching a clip of the boss in the game called Azag. He's a very scary creature that runs over you and damages you with his poison trail. That is, if he gets to you. You see, Azag has a problem. He's not very good at navigating. He simply runs towards the player's location, and if he encounters an obstacle, he just switches direction and tries to run towards the player again a little bit later. This makes for some awkward situations where Azag gets stuck and does not find the player, which is not scary at all, mostly just annoying since you have to go look for him. So let's fix that. The way we're going to fix that is with the use of a pathfinding algorithm. Most of you have probably heard of pathfinding, but for anyone that has not, pathfinding is about finding the shortest path between 2 points, typically with some restrictions. In our case, that would be the position of the boss and the position of the player, with the restriction that we cannot have the path go through the obstacles on the map. The algorithm I will use is called A*. I won't bother going into details on how that works in this video, since there are many good explanations of it on YouTube and the web that do a much better job at it than I would. Let's start with the most important thing in any solution, the data. For this algorithm, I need data representing the positions to pathfind to. I opted to use a grid defined through nodes with this path node struct. It holds the position of the node and what other nodes it is connected to. The other part of the data is specifically for the A* algorithm in the A* node struct. Each A* node holds which path node it represents, an estimation of the cost from this node to the goal, the cost from the start node, what index in the current path it is in, and the previous A* node in this path. This grid would be a uniformly distributed grid over the map, so the position of the nodes are just calculated from their indices in the grid. Here's the code for connecting the nodes together. The only special thing we do here is to check if there is any terrain colliding with a line between 2 nodes before adding a connection between them, since if the path between 2 nodes is blocked by terrain, then that should not be a valid path in the grid. Here's a look at the debug view of the grid to show the connections between the nodes. As you can see, whenever there is terrain in the way between 2 nodes, there is no connection between them. This is what will decide which paths are allowed for the boss to take and which are not. Next we need to find the closest node to a specific point on the map. We need this since the boss needs to find a path from any point on the map to any other point on the map, and we don't have an infinite number of nodes to cover it all. This code does the trick. It is just the simplest version going through all the nodes and checking the distance from each node to the given position to find the closest. The addition we have is that it checks to make sure the path between the position and the node is free from terrain, since the node has to be possible to reach without colliding with anything from the given position. And here's a clip showing my test of this function. It runs the functions on the player's current position and paints the node returned red. Then, if we combine this with the A* pathfinding, we get the following result. Here, the path from the position 0, 0 to the current position of the player is shown in red dots. The final step is to just hook up the new pathfinding to the boss behavior. So here you can see that working. So now instead of just running straight forward until he runs into an obstacle, he instead finds a path from the node closest to him to the node closest to the player. Then when he reaches that node, he will run straight to the player if that path is not obstructed by the terrain. If there is an obstacle in the way, he will find a new path from the node closest to him to the node currently closest to the player. There is also a limit in how long the boss will chase the player until he stands still for a little while. With this new boss behavior, you have to be a bit more clever to trick it, but it's still possible as long as you have unlocked the abilities needed to do it. That's all for this video. Make sure to check out the game on Steam and subscribe to the channel for more videos like this. Thanks for watching. Bye.